This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. This is Big Data Masters program. So, friends, if I'm going to recap what we have covered so far, recap to previous sessions, so we have gone through with what is big data, okay, and in order to go through with big data, what we have seen there are two main problems with big data, that is storage issue and processing issue. That is nothing but challenges with big data. Challenges with big data. Okay. So these were the two challenges. Once we are talking about big data and that is storage, like if we are having huge amount of data that is not able to fit inside a particular machine or in a monolithic machine, then how to taken care that particular problem. So storage is one challenge, and if we are having huge amount of data and until unless we are not processing it, that is not making any sense. So processing is also a challenge once we are having huge amount of data. Okay, so we have gone through with these particular things. Then what we have seen, in order to solve these particular issue, what we are having Hadoop. Hadoop is a distributed computing framework which is utilized in order to solve these particular issues which was there inside big data world once we are processing data with monolithic machines. So in order to solve this, what we are having Hadoop, and then we have gone through with what is Hadoop. So this particular concept we have seen. Inside Hadoop, what we have seen, its component, say component of Hadoop, then its architecture, and then what we have seen, say from the Hadoop side, HDFS is there and MapReduce is there. MapReduce. So we have gone through with these particular concepts as well. SDFS, that is nothing but Hadoop distributed file system, and which is utilized in order to solve the storage issue. And MapReduce, that is nothing but the processing framework inside the Hadoop ecosystem, and it is utilized in order to solve the challenge which is processing if we are dealing with huge amount of data. So Hadoop has you can say solved your problem which was there with big data, and we have gone through in detail about SDFS and MapReduce. Okay, so we have seen from these particular concepts we have gone through with Linux commands, then HDFS commands. Okay, in order to understand the functionality of MapReduce, we have gone through with certain Java programs. So up to so far, we have seen these particular things with respect to our learning journey. Yeah? And what I used to say, this is nothing but module one. Module one from our learning journey. Yeah? And over here, we have seen certain other stuff, uh, like how to execute the Java programs with MapReduce, with the help of Eclipse IDE. So this is with respect to the module one, and module one is just to give you certain insight what exactly is happening inside the big data world, what are the different challenges, and how we will be able to resolve those particular issues. This is like just to build your base. Now the next topic that we are going to start, that will be Hive, module 2, that is Hive. So from the Hive perspective, let me try to give you certain insight first, and then we will proceed further in detailed discussion. So what was happening in Hadoop? We are writing down the code in Java language. Let me write, we are for solving a particular issue, a particular issue with MapReduce, we need to write code in Java. Okay, because this Hadoop is able to understand Java, and Java, if we are writing down the code in Java, then it will be typical from the developer's perspective. For the smaller problem, he or she needs to write down the lengthy code. So need to write down the code in Java, or code in Java, right? Code in Java, and from developer's perspective, it will be it will be tough, and he or she needs to write lengthy code. Lengthy code. So what we have seen, for just word count program, we have written five, uh, we were having five classes, and inside the five classes we were having, in each of the class we are having uh, 10 to 15 lines of code. And because of that particular nature, the code is became very lengthy, and it is like tough to learn Java as well, because like all of the persons are not familiar or not comfortable with Java. So, what the industry was looking for at that moment, what was there? We are talking about certain past. So, we were having a lot of persons who are working on to the SQL, SQL. So, people, if we are talking about the software industry, almost 60 to 70 persons developers are having the knowledge of SQL, and they love to code in SQL. They love to code in SQL because that is very easy in nature, and it is very able to digest that particular language. That is structured query language. SQL is very easy. That is structured query language. Structured query language.
But Ashok, this SQL will work only on tables, na?
Yes, that is working on tables.
But if
That is
the
working on
data is in if the data is in unstructured format, then
So, for the unstructured format, like what we are willing to perform with the unstructured data, that is the main stuff. Like if we just want to read the data, and then we need to like create a schema. It is like, say, for the unstructured data, say we are having audio or video. What we are going to find out with that particular unstructured data. Okay, so for that perspective, like we are having different things, and what we are like willing to perform with that particular structured data, like say we are having certain audio video files, and on top of that, like we need to we need to perform certain rating like mechanism. Okay, so at that moment, like the SQL will work over there. But yes, for the unstructured data, we will not be able to do the analysis based upon the SQL. What we need to have at that moment, we need to add certain intermediary tool which will be utilized in order to pre-process that particular data. You can think like you are having certain data from the or tweets from the Twitter, and it might be possible those particular tweets are uh, in different language. Like say some of persons are writing tweets in English, some of the persons writing tweets in Hindi, some of the people writing tweets in say Russian language. So at that moment, what we are going to do, we are going to collect those particular tweets, and we try to pass those particular tweets from certain uh, NLP, natural language processing algorithms. And at that moment, what we are going to do, we are going to segregate based upon our use case, like this is the positive keyword or negative keyword. So once we are having that positive, that bifurcation of positive and negative keywords, okay, then that can be structured in a form of table, and then that particular, you can say, data will be utilized for the processing perspective, right? You need to take certain intermediary steps, right? I have
Okay.
taken an example. Okay, so you are very right over here. You're correct over here. Like we can't process unstructured data with SQL. SQL is utilized for the structured data processing only. But if you need to utilize SQL in order to process the unstructured data, then you need to take multiple steps based upon the flavor of your data. Like what is the end outcome that I'm looking for with respect to this particular data. Okay, at that moment you can say, yes, my use case was in this particular direction, and uh, I have like pre-processed certain data, okay, in order to convert it into the structured format, and then it will be given for the processing perspective, right? So you need to add certain intermediary steps, and to be very frank, Pankaj and all, like in this particular world, like we are having very less unstructured data that we are leveraging for the business revenue, for the for the for boosting our business revenue. Okay, so we used to prefer structured data, and most of the organization, even in my current organization, even like inside the telecom sector as well, we used to process structured data. Unstructured data, that is like, say we are having certain X-ray images, and we need to
Yes,
find
yes,
out
correct.
okay, so X-ray images, we are having certain log sheets. We are having certain handwritten copies of certain students, and we need to do the analysis, or we need to check those particular sheets with say uh, machine learning algorithms and all. So we need to take certain intermediary steps, okay, and then we can leverage SQL for the processing perspective. It is not like, say, directly we can feed unstructured data to the SQL and it will be processed. That is not the case, right?
Yes,
Fine
yes,
so
Ashok.
far?
Yes, yes, absolutely.
Perfect. So, structured query language. So, people were looking for a solution that they can code, uh, like they can code in SQL query, in SQL, in order to solve the vast problems, or you can say big problems. So they were looking for a solution. So inside the Facebook, in Facebook, they were having huge amount of data, and they were having the talent of SQL. The people like over there who were working over there, they were having the knowledge of SQL, and they want to leverage this Hadoop as well. So what they have done, they have built a solution named as Hive over there. And what can I say? Hive is built by that Facebook, in order to solve the big data problem or big data challenges what they were facing. So what exactly is happening inside Hive, and it is working on HQL. That is Hive query language. That is like similar to SQL only. Okay, I as it is utilized for, you can say, processing the data inside the Hadoop. So what we can say, that is the HQL, Hive query language. So Hive. Now, what exactly is happening over here? Say I'm a developer, and I'm going to write down the code in HQL. and it will be given to Hive. Okay, and Hive is going to convert that code into say Java internally, and that particular Java code is given to MapReduce for the processing perspective. MapReduce for the
Hive is
processing.
ID or Hive is a tool?
It is a tool. This is not an ID. It is a tool.
Okay, okay,
Okay, it is a framework basically in order to process huge amount of data, right?
okay, okay, okay.
Okay, so being a developer, we just need to write down the code in HQL and it is given to Hive. And Hive is like going to convert, that is acting as a converter, it is going to convert into the Java and it is given to MapReduce because MapReduce is able to understand the Java code only. What we have seen it. Okay, we have gone through with the word count program and over there we have seen like we have written the code in Java and we were able to get the outcome with respect to our word program. Okay, so that is with respect to Hive. Now the life of the developers will become very easy and and the and they will be able to solve the big data challenges. Now one thing is there. Okay, SQL or HQL. We were having certain tools like say SQL was there. That was there. We were having Oracle. Oracle was Oracle was also there. Certain tools like Postgres and all. Postgres SQL. PostgreSQL. So PostgreSQL, PostgreSQL. So these particular tools or another like MariaDB. Okay, a lot of structured, a lot of tools were available which were working onto the SQL, structured query language. But why we need to have Hive? Why we need to have Hive? We were having these particular tools, these were working on SQL, and with the help of these particular tools, we were able to do the analysis. But why we need to have Hive? Just think for a minute and tell me why we need to have Hive. We were having these particular tools in order to do the analysis on structured data. We can utilize these particular tools, but why we need to have Hive? In Facebook as well, they were having SQL, Oracle, Postgres, or MariaDB. They can use any one of the tool in order to do the analysis on their structured data, but why they were in need of Hive?
Mm, and these languages are only for monolithic purpose, na?
Perfect. So these are working onto the monolithic way. Okay. Monolithic way of computing, way of processing, what I can say. Processing. So over here, only single machine is there which is able to process on top of your data. Okay, but if the data is very huge, if data is say big data, then these particular tools will not be suitable to process on top of that particular data. If we are having the distributed mechanism, the data is placed inside the multiple machines, then we will not be able to leverage these tools for processing our structured data. So it is working into the distributed computing framework. Distributed computing framework. Framework. Now you can think we know say SQL, that is very easy. Like I will guide you. I will provide you the material how to learn SQL and HQL. If you know SQL, then you are the champ. You will be the champion in SQL, Hive. You will be able to write down the complex Hive code. And I will guide you how to learn SQL and all. No need to worry on to that aspect. Now you can think you are having the say knowledge of Hive or SQL, then you are the champion of Hive. You will be the champion of Hive, and then there is no need to learn Java. And that's why in the session of MapReduce, as I was saying, there is no need to learn Java over here for the for the learning journey, we are just going through with the simple basics like how MapReduce is work functioning in the back end. And in order to get the understanding about functioning only, we are going through with these Java codes. There is no need to learn Java for this particular learning journey. We just need to learn certain tools which are in demand in this particular, you can say, software market at this point of time. And there is no need to learn like the complex or you can say difficult programming language and all. Okay, so that is the motto, and intention is to reduce the line of code and make the life of the developers easy. Yeah. Okay, so developer's life will be very easy, and he or she needs to write less lines of code in order to solve a particular problem. That is the intention of learning Hive. And from where it came from the Facebook, because they were having the talent. It was developed by Facebook. Moving further, let me try to give you certain insight as well. In this particular world, we are having two types of systems. Number one is traditional system or transactional system, sorry, transactional system. And number two, that is analytical system, analytical system. Okay, so transactional system and analytical system. Once we are talking about the transactional system, so it is dealing with uh, say insert, update, delete. These particular operations are there once we are dealing with the transactional system. For an example, say example bank ATM. Bank ATM. Bank ATM. Okay, it is dealing with insert, update, and delete, and require low latency. Latency. So just try to keep these particular things in your mind. Transactional system require low latency, and operations what we are going to perform insert, update, and delete. Okay, so I have quoted the example for bank ATM. Say you can think in this particular way, like I want to withdraw 5,000 rupees from my account, and I have like visited to a bank ATM, and I swiped the card, and I have done the withdrawal of 5k rupees from my account. Now instantly, like I will be getting the SMS like you have done the transaction of 5k rupees, and in the same fashion at the same instant, what will happen, the amount will be debited from my account, and it will be reflected inside the bank server as well. Each and everything will happen in real time. Real time, like operations, real time operations basically. Over here we can't afford the latency. So low latency requirement is there. So these are nothing but the transactional system. Now on to the second hand, what we are having uh, real time data or operations, what I can say. Data, public operations. On the second hand, what we are having analytical systems. Once we are talking about analytical systems, over here we are dealing with the historical data. Dealing with historical data. Okay, dealing with historical data, it means like say we are having the data of a particular network. Say we are having the data of Airtel Delhi, and we are having the data of last 5 years. Now we need to do the analysis. Okay, like what is the monthly drop rate or throughput for this particular say RNC, BSC, whatever. Okay, you just want to do the analysis. So over here, are you dealing with real-time data? No, you are having just historical data. You just going to perform the analysis based upon last 5 year data. It might be say last hour, last hour, last one day, 24 hours. Okay, 7 days, 1 month. Okay, history can be anything over here. So you are doing the analysis on top of historical data, and at this moment, are you going to update? No. Yes, you can delete some record, but insert is not there. So what you are going to do? Read and update is not possible. Read is the uh, operation which we are performing over here. Over here. Okay. So we are dealing with historical data, and read is the operation what we are going to perform over here. Okay, that is the analytical system. We are dealing with history. Okay, and over here, say delete, what I can say remove from here. We can't, we are not willing to delete. Okay, update we can say. Over here, what we can have like read and delete we can do. Like if you don't want, uh, if you want to remove certain data, what I can say outlier. Okay, if you want to remove that particular outlier, then you can remove from this particular historical data. Delete up to some extent. Delete records up to some extent. So that is there once we are dealing with the analytical system. It's very like with the name itself we are able to get the information analytical once we are dealing with the historical data, and over here latency is high. Yeah,
But
is
Ashok,
high.
if delete is there, then it is a kind of update, na?
Delete is like yes, we can say update, but insert is not there. You can think
Okay,
insert is insertion of new record. Okay, delete is like say we are having certain outlier. Like am doing the analysis of say last 1 year, and because of certain events, the traffic was surged, and those particular days are creating problem in order to have the analysis. So what I can do, I can remove those particular records or drop those particular records for the analysis perspective, right? That is delete, right?
okay.
Okay,
Yes, yes.
so you can like whatever you are going to perform for the analysis, that can be parked inside the analytical system. Okay, and latency is high. Latency is high. Why so? Because like say I'm having uh, billions of records, and in order to process billions of records, it might be possible it will take say 1 hour, 2 hour, 1 day, 3 days, even like it might be possible it is taking say 7 days in order to process. Okay, so latency is very high over here, but we can't afford high latency over here inside the transaction system. Say I have done the withdrawal of 5K from my account, and if it is not reflected inside the bank server, then like bank will suffer. Okay, so that will be an issue. And say if in case of say joint account, like two persons are having the the two ATMs of same account, then it will be tough. Okay, so over here we need to have low latency, and we need to perform the transactions in real time, and real time we are going to handle the real time transactions or real time data over here. Okay, over here like if we are not getting the result uh, in 1 minute, then in another minute one we can have Okay, it might be possible. Now, over here, the data processing can uh, take any time, depend upon the resources that you are going to put, depending upon the size of data that you are having, depending upon the business requirement as well. Say, it might be possible, like say you want to have the we are getting the ropes of data. We are getting the ropes of data, say every 15 minute, inside the telecom we are getting a new rope of records. So how we are getting, because the processing is happening at the OSS level, and at the OSS level, measurements and all those particular uh, things or calculations are being happening, and it is taking almost say 14 minute or say 10 minute in order to do that particular operations, and then we are able to get the rope at every 15 minute. So data is available. So it is based upon the business requirement as well. Apart from this, like if we are talking about say 2G, where like we are getting the stats at early level. So that is based on the business requirement. Even though like we can process, we can have uh, we are having the records, but it is going to increase the load of OSS where the processing is happening. Okay, so further what you can do, you can further do the aggregation and all onto top of that particular data or ropes, and you can uh, have the analysis on daily basis, hourly basis, monthly basis, or yearly basis, whatever you want. So latency, it is not real time, and the latency is high over here if we compare it with the transactional system. So two types of systems are there in this particular world. And you might be worried, like we have started our journey with Hive, but why we are going through with these particular systems? So once we are talking about transactional system, then RDBMS is best suitable for the transactional system. RDBMS. And once we are talking about the analytical system, so data warehouse are the best suitable. Data warehouse. So analytical system, data warehouse are the suitable, you can say, stuff in order to process uh, with with analytical system. Now, what I have mentioned, like we have started our journey and we are discussing about analytical system or data warehouse. Now, the Hive is nothing but the data analytical system. It is data warehouse which is utilized in order to solve the analytical problem. It is not the transactional system, right? It is not meant to deal with the transactional data. It is meant to deal with historical data. Okay, and where we will be able to get the outcome with high latency if we compare it with the transactional system. Okay, so Hive is meant to solve analytical problems, and it is open source data warehouse. Data warehouse. So we have used two words over here, RDBMS, that is nothing say relational database management system, and we used to say database. Okay, database and data warehouse. Database and data warehouse. So RDBMS, that is used for the transactional system. Over here latency is low, and SQL, you can say, tools. Okay, SQL, you can say Postgres, Oracle, these are the tools with which we will be able to process, and we will be able to get the outcome. Over here latency is very low, that is true. Okay, and cost is very less at this moment. Like over here cost is very less because like we are dealing with less amount of data, and the cluster, no cluster is there, only monolithic processing is there. But once we are dealing with the analytical system, say Hive warehouse, so we will be having uh, cluster and all. We are dealing with huge amount of data, and latency is more over here. It is not meant to work with less amount of data. Once we are having huge amount of data that is not able to fit inside the transaction systems or RDBMS, then we are going to leverage data warehouses. Fine so far? Anything that you want to ask, friend? Anything?
Fine.
Anyone? Any
Ashok,
doubt?
Fine.
Mhm.
what actually it is data warehouse?
Huh, data warehouse. Huh? So data warehouse over here, like let me mention data warehouse. Huh? So we are having three main things: database, data warehouse, and data lake. Huh? Data lake. So latency low. These are nothing but we are going to categorize the tools into these particular category. Huh? Okay, latency low, uh, data in row and column format, and say Postgres, QL, MariaDB. These are the examples of database. Huh? Now, once we are talking about data warehouse, so data warehouse is nothing but like distributed data processing framework, data processing framework, framework. And over here, like we are working with huge amount of data, latency is high over here. Latency is high if we compare it with say database. Okay. Now another main thing, uh, it is best suited for ETL operations. ETL operations. Now ETL is something. Let me show you. So say we are having data source one, or what I can say source one, source two, source three. Okay. So over here, what we are having raw data. Okay, raw data. Okay. So over here we are having raw data, then ingestion will happen from these particular source, then transform, and then load in data warehouse. Warehouse. So just try to focus over here, friends. We are having different sources. Over here with the help of database, like we are not having the distributed computing framework, and it is dealing with less amount of data, and it is as it is processing less amount of data, so latency is very less over here, and data mentioned in row and column format, that is nothing but table format. Table. Okay, so data is available in table format, and different, these are the examples with respect to the database. That is perfectly fine. Now over here distributed computing framework is there, and latency is high if we compare it with database. Now over here just try to focus, we are having different sources, and what we are going to do, we are going to do the ingestion of the raw data which is there inside these particular sources. So we can leverage any ingestion tool over here. Now what we are going to do, we are going to do the ingestion like it is what exactly is happening. Say over here we are having 500 columns. 500 columns are there. Say source one is having say 500, it is having 200, 300, whatever. Okay, each and every source is having 500 columns. But what for the business use case, what I want to have, I just want to have 50 columns only from the data. You can think the raw data basically. Raw data or raw counters that you are getting inside the say PM report. PM report or CM report, you are getting say 500 counters, but for your operations you want to have 50 counters only in order to calculate a particular KPI. So what exactly is happening? It is going to extract the data from these particular sources. Ingestion tool is going to perform this particular task. Like I want to have these particular uh, counters. It is going to transform. Like instead of 500, it is going to take 50 only. So extract then transform. It is going to do like if required certain processing. So over here like certain addition deletion can happen, and then it is going to load it inside the data warehouse. So it is best suited for data warehouse or best suited for the ETL operations. Because why we need to perform, why these are suited for the ETL operations, because it is not like to move entire all the laundry list to the data warehouse, and it will be have the refined data, and then whatever the logic you are going to apply on to top of that particular data which is available inside the data warehouse, then you will be able to get the outcome with low latency. So further processing will happen and you will get the final output. You can think in this particular way. Say output. You can think in this particular way. You are having 500 counters. You have selected 50 counters only, and you have prepared a table inside the data warehouse. So it is also working in say row and column format. You will be having data in tabular view. You will be having the tabular view. Okay, and it is available inside this particular data warehouse. Now further, if you want to do the processing, you can process that particular data, and finally you will be having the output. So the data warehouse are best suited for ETL operation. That is the thing. And we have seen this is nothing but a ETL flow. And if we talk about the example, so Teradata, example of data warehouse. Data warehouse. So Teradata, Redshift, AWS Redshift, Amazon Redshift basically, Redshift, Hive, Vertica. Okay, these are nothing but the examples of data warehouse. Fine, with respect to the data warehouse.
Ashok,
Mm-hmm.
hello. Just a
Yes, yes,
one
please ask.
question there. Yeah,
Mm-hmm.
like you mentioned, like we have, for we can consider 500 row data here, and
Mm-hmm.
we are uploading the 50 column data on the uploading the data. So, is there
Mm-hmm.
in between we need to write the query, or automatically is converted by the transform, like, or we need to write the query for selecting the 50. I'm taking the
Yes,
example from the raw data. So we need to write
yes,
the
yes, yes.
query, or
We need to mention. Okay, we need to
okay,
mention. So basically, what exactly is happening? These are nothing but say certain SQL sources. The data is available in terms of say SQL tables over here. Okay, this is nothing but these are nothing but say SQL sources. Or say we are getting from any source, and what we can do, we can create a table on top of that, and we can move it inside the SQL format or inside the RDBMS. Now what we can do, we are having say multiple RDBMS or uh, certain say live sources. Then what we need to do, we need to do the ingestion with the help of a particular tool. So I have not covered one tool, that is Scoop, or what I can say Scoop is there, which will be utilized in order to extract or ingest the data from RDBMS to HDFS. Say what we are having a particular tool that can import, say over here RDBMS, and over here we are having say HDFS. Okay, if you want to move data to and from HDFS, RDBMS to HDFS, and HDFS to RDBMS, then you can leverage Scoop. If you are having certain data, you can move it inside the HDFS. If you are having certain data in HDFS, you can move inside the RDBMS. So we can leverage Scoop. We are having different tools inside the market. Okay, so we can leverage we can utilize glue over here as well. Okay, AWS glue. Okay, different tools are there, with the help of what we will be able to do the ingestion. And during ingestion we can specify, like I want to have this particular counter from this particular table, and that particular counter will be ingested inside the data warehouse, right? Fine, we can specify.
Yes, okay, fine.
Okay, so let me try to show something. Let me try to show you something. Data ingestion tools example. Photos. I'm just like randomly selecting certain images in order to give you certain insight. Okay, just have a look over here. So you are having data source API, right? So over here, data source API, it can be anything. Like it can be a data lake, it can be HDFS, it can be a file, right? Right? Hello, are you with me?
Yes, yes, yes,
Yes,
Ashok.
yes, okay.
Yes, yes, Ashok.
Okay. So we can have data like, say we are getting the streaming data, live streams of data. We can have change data capture, or we can have certain batch files as well. CDC, that is nothing but change data capture. Okay, so what we are having, row object store and landing area. So over here we are putting the row records. This is nothing but object store. It can be S3. Like this is this is the storage area where you are putting the entire data. Now what you are going to do, you are going to perform the ETL. That is extract, transform, or load. Okay, so ETL, and with respect to the ETL, what you are doing, you are moving certain data inside the data warehouse, and you are moving certain data inside the data lake. Okay, so we will be going with data lake as well. Okay, so data lake and data warehouse and data lake. Okay, so over here just have a look. So the data which is available inside the data warehouse, with the help of this, what you are going to do, analytics, or you are going to prepare certain dashboard, business intelligence. That is nothing but BI tools or certain dashboard. So you are having less amount of refined data over here. But over here data lake, what we are having entire row records. All the raw data will be available over here. Okay, and raw data, or it can be, you can say, historic complete historical data with respect to all the records or counters that will be utilized in order to apply AI and ML algorithm. Let me pick one more diagram. Data ingestion. This is nothing but data pipeline. So data sources, you are getting the data sources say from the cloud, from particular sensors, or from files from a particular S3 location, or from a particular network. Then the ingestion is happening into different formats, streaming, CDC, batch. Almost the same diagram. This is the same diagram. This is the same diagram. So 7 data ingestion tool. I is showing the example with 7 data ingestion tool. Diagram is not so much correct. Okay, over here probably. Okay, so that is good. Uh, Are you able to see this particular diagram? Over here, ETL and ELT, right? ETL and ELT, that is extract, transform, and extract load. Extract, transform, extract, load, and load. Then what you are having, data warehouse. Just try to focus over here. Data warehouse. Okay, and load, and after this we are having data warehouse. Then over here, like what we are having extract and load, and then we are having data warehouse, Snowflake, BigQuery, Amazon Redshift. These are the data warehouses. And extract,
So
load.
what is this
Mhm.
ERP CRM?
These are nothing but data. CRM data, ERP data, billing data. These are the types of data. Different S3 buckets are there. These are the S3 buckets. Based, you can think transmission data, RF data, okay, sales data.
Okay.
Okay. These are nothing but types of data, types of different flavored of data in a particular organization. Let me try to explain data lake over here, and then you will be able to get the understanding of that particular diagram. Now, inside this, almost like the same stuff is there, but a little bit change is there. So over here, what exactly is happening? Yes, we are having all the data sources, whatever we have seen inside data warehouse, but a little bit change what is happening over here. Ingestion is happening, then we are going to load the data in data lake, and after that transformation will happen. ELT, transformer. So that is ELT, extract, load, and transform. In the previous, what we have seen, extract, transform, and load. And over here, what we are having, extract, load, and transform. Extract, transform, and load. This ETL. Okay, so data warehouse are suitable for ETL operations, and we just want to transform first and load the refined data. But there is one challenge with the data warehouse. One challenge is what you can think. I'm taking the example from the telecom only. Okay, these sources have generated the data. They have given the raw data, and now inside the data warehouse, what we are having refined counter. Okay, 50 counters are available only. Yeah, but say now the formula has been changed and we want to have say five more counter in order to prepare a KPI. Then what we need to do, we need to perform this particular ingestion once again. Okay, because we are not having those particular five counters, remaining five counters are not there. These are available from these particular sources, okay, which we got from these particular sources. So we need to perform the ingestion again, and that is challenge with, you can say, data warehouse, because they are not having the entire raw data. Complete raw data is not available inside data warehouse. They are having the refined records. uh, uh, if we talk about these data lake, what we are having the entire data, and then we are going to perform apply transformation, like say selecting 50 counters over here, and then we are working. So raw data is available inside the cluster. Raw data is available inside the cluster. In the previous example, once we are doing the ETL operations, raw data is not available inside the cluster. But this is able to, you can say, perform the operation in with low latency, because it is dealing with say less amount of data. It has like done the transformation during the ingestion portion only, and over here it has like extracted the entire data, loaded inside the data lake, and then transformation is working over here. Okay, and that's what we are able to see over here. So ETL, like we are having different sources, then it is going to extract and transform, and then it is going to load the data, and then we are having the data warehouse and all in order to process this. So data warehouse and all, these are working best suitable for the ETL operations. Now, once we are having ELT operations, then what we are going to do, we are going to perform the extraction and load. Load is happened over here. The loading is happened over here, and then we are leveraging the data warehouse for the processing perspective. Like it can work on to huge amount of data. So over here the latency uh, will be less, and then the transformation will be done over here, and that will be again the time consuming process which was happened earlier over here. Right, are you able to get, all of you, are you able to get with the help
Le-
of this
le-
particular?
Latency will be low in ETL, na?
Yes, yes, definitely it will be low in ETL.
Yes.
So this XDBT is data lake.
Where DBT?
Yeah,
No,
yeah,
no, no,
yeah. This
no.
where it
This is build tool, build tool.
build tool.
You are like writing down the transformation mechanism over here.
In both picture data warehouse is shown only. Where is because the LT operation in happen in data lakes. No?
Actually, actually, the thing is that data lake is available over here. You are loading the data over here. This is nothing but
Okay,
data lake. Say this blue pipe is nothing but data lake. So
okay,
inside data lake, you are having data. Okay,
uh,
inside
okay,
data lake, you are having data, and that is raw data basically. Over here,
okay.
you can directly move the data inside data warehouse. These are nothing but machines basically. BigQuery, Amazon Redshift, these are nothing but combination of multiple servers. Either you can load the data directly in these particular machines, okay,
Mhm.
servers where Redshift is running, or you can put the data inside S3. You can have S3 as well over here, and then you can align these resources for the processing perspective. Okay, right. So these are nothing but machines or solutions basically that is utilized in order to process huge amount of data. ELT, you are dealing with entire raw data. Over here, you are working with the refined data. That is the you can say difference. Transformation will happen. You can say at the later part inside the ELT. Over here, it is like going to transform first, and then it is going to load. It is load first, then transformation will work. Right, right,
Right, right.
Yeah.
So
and
data
my
Ashok,
lake is
friends,
not any machine.
data lake is object store. That is HD like HDFS. And processing is not there. Processing is not happening over there. S3.
Okay,
Okay. These tools, say data warehouse can pick the data from data lake for processing perspective.
okay, okay.
Okay. So I have not mentioned this like data lake is distributed data processing framework. This is not data processing framework. Or what I can say distributed data storage mechanism. Data storage mechanism. Okay, distributed data storage mechanism, and best suited for ELT operations. ELT, sorry, best suited for ELT operation. Fine.
Fine, fine.
Ashok,
That's
can you please explain this with in context of Hadoop, the end-to-end components, whatever we have discussed?
Okay, okay.
Uh,
So with context to Hadoop, say what we are having raw data. So raw data, and what we are going to do, we are going to do the ingestion. Forgot about this particular tool, and this is nothing but raw data, and we are going to perform the ingestion. And what we are having HDFS. HDFS, that is nothing but data lake. This is data lake. HDFS is nothing but data lake. Now we are having data inside the HDFS. Then what we can have, we can Hive for the processing perspective. This is nothing but data warehouse. Data warehouse. Okay. So so once you are going to perform say ETL operation, say ETL. Now it depends on you. How, and for the Hive, the backend storage is HDFS only. Okay. Hive, let me mention over here. Hive is having two part. Is having two parts. Or Hive tables basically. Tables are having two parts. Number one is actual data, and number two metadata. Metadata. Okay. Actual data, it resides in data lake. That is nothing but HDFS. And metadata, it resides in uh, RDBMS. That is MySQL over here. MySQL. Okay. Now, so if you are going to load entire data, if you are going to first say perform ETL operation, so what you are going to do, you are loading the data from all of these particular sources, and say if you have selected the required counter only or extracted the required counter only, and then you have loaded it inside the data lake. Okay. Further, like Hive will be utilized for the processing perspective. That is with respect to the ETL. Okay, now if you have loaded the entire data, like all the files and all have been loaded inside the HDFS, then we are going to leverage Hive or any another tool for the processing perspective, that is ETL. These are the terminology, friends. Like, are we moving with the entire raw data, or are we moving with the refined data? Okay, or filtered data basically. So what will happen over here, if we are moving with the entire laundry list, then the processing will be taking much time. That's why like latency is high over here. High latency. If we compare it with data warehouse. Okay, data warehouse. So in the Hadoop terminology, same like we are having multiple source, we are performing the ingestion, we are putting the data. If we are putting the data, entire data inside the SDFS, okay, then we are going to leverage say Hive or any other another tool for the processing perspective. Okay, so over here at this moment, it is going to work onto the you can say huge data. Then like it first need to transform it, you need to extract the utilized data, and then like the processing will happen. Same what we are able to see in this particular diagram. We are having raw data. Okay, we are putting first is extracting and transforming it and loading it. So load is done where inside the data lake. Then we are leveraging the data warehouse. Okay, so less amount of data is available over here at this moment. But once we are doing the ELT operations, we are having the raw data. We are performing extract and loading. So we are extracting from these particular sources and we are loading it inside the S3. Then we are leveraging data warehouse for the processing perspective. At this moment, transformation will happen and we are able to get the output. Same stuff, right? Fine so far?
Yes, of this
Uh,
Hive output will be given to further map reducers and all that part, right? And we will get the final
Yes,
output.
yes, 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 yes. Okay. Even like once you are going to work with Hive, okay, you are going to write down the code in what? In SQL language.
SQL.
Okay,
Mhm.
HQL basically, Hive query language. So it is going to accept the code in SQL like language, and it is going to convert this particular code in Java, and that will be given to MapReduce. Right?
Fine. Thank you.
Perfect. All of you friends, fine so
Yeah.
far?
Excellent. Yes, Ashok. Fine.
yes, yes, Ashok.
Okay, perfect. So, if we talk about the HDFS, over here, the data is placed in terms of files. In in HDFS, the data is placed in terms of files. Now, intention to have Hive, like, can we do the analysis, or can we do the analysis by writing the SQL queries? SQL queries. Yes, we are able to. So intention to have Hive. Huh? This is the first one. Like, can we write down the code or can we write down the SQL queries for the analysis perspective? Second one, can we visualize the data in terms of tables? Huh? Tables. Okay, so these are the two intentions what we are having. So yesterday what we have seen over here, like we are having certain say files which are available inside the Hadoop. Say Hadoop fs-ls, and we are having certain data available user Cloudera, and let me check what is available over here inside the test, say inside test. Let me check inside the test. Sorry, I need to copy. Output to and we are having certain partition files. So I just want to get the data Hadoop fs-cat, and I just want to get the data from this particular file. Copy and let me paste it over here. Okay, it will throw error. One forward slash is missing. Okay, so it will provide me the data. So this particular data is available in a particular file. Now my intention is to write down the SQL queries for the analysis of the data which is placed inside these particular files, and I just want to visualize the data in terms of table. My intention is this. Over here, like this is not, you can say, looking in a good way, and I just want to do the analysis onto these particular files, and I just want to display the data in terms of tables. If we are talking about say MySQL hyphen u root hyphen p Cloudera. Okay. uh MySQL hyphen u. Mhm. Hmm. So I was typing wrong password.
Ashok, what is MySQL?
This is RDBMS. Okay. So here is not working. Okay. So just have a look. Show databases, and over here say what we are having. We are having certain databases. Now what I can say, retail DB. copy, use retail db. I'm just going to utilize retail db database, and over here inside the retail db database I'm going to list say tables, show tables. So categories is a table that is available over here. So select star from categories and say limit 10. I just want to have 10 records from this particular table. Just have a look. We are able to see these particular records in a good visualization. A visualization is very good over here. And I'm able to do the analysis. Say I just want to have 10 records, 50 records. I can like do the analysis in such a way. Say I'm having two tables. I can join two tables. Okay. I can do the analysis by writing down the complex queries, but that is not possible once we are having data uh, in you can say hdfs, and we are like if we are going to write down the complex code in java at that moment as well, like visualization is not good over there. So our intention is to get the data, or get the analysis, do the analysis in terms of these particular tables, and visualization, visualize the data as well. That is our intention in order to have Hive. Now, once we are going to work with Hive, what I have mentioned, these Hive tables are having two parts. One is actual data and second one is metadata. So actual data is residing inside the hdfs, that is hadoop database, hadoop distributed file system, but metadata is residing over here inside the mysql. So show databases, what we are able to see over here, meta store. Let me try to copy this meta store, copy, use metastore. I'm going to change the database and show tables. Inside this meta store, I'm going to check the tables. So inside this meta store, I will be having the information about the table which I'm going to create in Hive. Okay, this mysql meta store is nothing but utilized in order to maintain the metadata of Hive tables. So Hive logs, global parameter function. Okay, these are different, you can say, parameters with respect to a particular table. So TBLS tables, transactions, transaction components, serialization, deserialization. Okay, serialization, deserialization, shared parameter. That is serialization, deserialization parameters. Skewed columns we will be learning in detail. Okay, we will be going to apply certain optimization techniques inside the Hive tables, and those particular things will be available over here inside the meta store. Now what I have mentioned, actual data will be residing inside the hdfs, and metadata, that is nothing but data about data. Okay, so that will be available inside the mysql. So we are going during our learning journey, we are going to create the Hive tables, and we will be trying to load certain data on the Hive tables, and then we will see the data is available inside hdfs and metadata over here inside the mysql meta store. We will be having the entries for metadata. So we will see these particular things, like if we have applied the bucketization now, that is an optimization techniques inside the Hive table. In order to optimize the Hive table, we can apply bucketization. So we will see on which column we are having bucketization over here. We just create the Hive tables. Okay, so let me try to say start. So Hive. So if I'm going to type Hive over here, Hive will start.
So before going forward, can we just have small discussion related to your meta store or metadata? Like what kind of interview questions can be asked related to that?
Okay, okay. So, with respect to this particular metadata, let me try to mention inside the Hive or inside the Hadoop, the default RDBMS is Derby. Derby. So once we are talking about the RDBMS, which is utilized to maintain the metadata of Hive tables. Once we are going to create Hive tables, then its metadata is maintained inside the RDBMS. But Hadoop is having default RDBMS, that is Derby. But Derby is having certain limitations. Inside the production environment, Derby is having a lot of production issues. So what the Cloudera Quick Start VM has done over here, they have like created MySQL as a database, and MySQL is utilized as a meta store or RDBMS, and it is used to maintain the metadata of Hive tables. Default is Derby, but over here we are having MySQL as RDBMS to maintain the metadata data of Hive tables. Hive tables. Okay, so this is nothing but metadata. MySQL is utilized in order to maintain the metadata. Now, once we are talking about this metastore, so metastore, inside this MySQL, what we are having a database metastore, and this particular metastore is having these particular tables. Let me try to copy tables in MySQL metastore to maintain the metadata of Hive tables. These are tables inside the metastore. Let me try to check, say, select star from bucketing columns. This is a table, and let me try to display the information. Select star from bucketing columns. Bucketing underscore cols. So empty. So it is not having any record at this moment, probably like we have not applied the bucketing. Once we are going to apply the bucketization on the Hive table, over here we are going to we will be going to create the Hive tables, and once we are going to apply the bucketization on a particular column, then that particular entry will be available over here inside the bucketing. So what I'm going to say, uh, say if you have applied the bucketization on a particular table, in a particular table, on a particular table in a particular column, then that particular entry will be visible over here. Let me try to check the details of TBLS. Select star from TBLS. That is another table inside the all of these particular tables are not having entry. Okay, let me check. Types, TBLS. So as we have not created any tables, Swati and all. So as we have not created any tables inside the Hive, so we are not able to have the entry at this moment. Once we are going to create the tables inside the Hive, then we will be able to have the entries of those particular tables over here. Okay, so like once we are going to create tables over there, then we will be able to see these particular properties. Say if tbls, then its entry will be available over here, and entry with respect to the details or schema of that particular table which we are going to create in Hive. So those particular entries will be available over here. Once like we are going to create tables, then we will go through with different parameters about from this particular meta store, right?
Okay, sir.
We will
So,
create tables,
in one of the
just a
interviews,
minute.
now I was being asked like, is it possible to change the default database, that is Hadoop Derby, to something else? Is
Yes,
it
yes, you
possible?
can change, you can change.
So
So these
nowadays, like in production, what we use, like as you said, Derby is having some pros and cons for related to your Metastore. So your Cloudera Quick Start VM has given you the SQL alternative. Then what is happening in the real time, like in production?
just a minute. In production, you can give mention like I have utilized my PostgreSQL, or I am going to use say RDS, Amazon RDS. Okay, depends. And from where you can change this particular default database. So we will be having Hive over here. Let me show you Hive and configuration and Hive site.xml. Okay, inside hive.site.xml we will be having the details, like MySQL details, that will be working as a meta store, right? Hive execution parameter. So meta store is this one, right? So on this particular port, your meta store is available. So from here, say if you are having Postgres or RDS, or MariaDB, you can just change that particular uh, metastore from here. Then that particular tool will be utilized as a metastore, right?
So MongoDB can be used.
MongoDB, that is not RDBMS, that is no SQL database,
So in your like in real scenario, what is being used then? Like in like in max of the organizations, what we can say if
uh,
this thing is.
in my organization, like we are preferring Postgres, basically the main thing is that try to think over here, why we need to have metastore, why we need to have metastore to maintain the metadata. And why we need to maintain metadata, because it will be tough to query onto the data lake, like if we are maintaining the metadata inside the data lake, then latency will be very high at that moment, and Hive is not meant to like to deal with the queuing mechanism, like or like once we are going to query onto the data lake, then latency will be very high. For this, you can say simple metadata related stuff, we need to query, if we need to query onto the the data lake, then that will be taking much time, huh? So what I can do over here, I can move the metadata inside the RDBMS, huh? Now RDBMS, they are going to provide the low latency. Now you mentioned the metadata I can store in NoSQL DB, NoSQL DB, NoSQL DB database. That is MariaDB. Oh, sorry, MongoDB. MongoDB. Definitely, you can maintain the metadata inside the MongoDB, but there will not be any use. Okay, why? Because over here, this particular RDBMS is working into the monolithic way. Okay, and these particular NoSQL databases are working into the distributed mechanism. Do we need really require? Do we need to put our small data distributedly onto the multiple machine? Is it really require stuff? Huh? So small data is there. Instead of like maintaining it, uh, the small data onto the different machines. So what I can do, I just put it inside one machine where from where like it will be very easy to fetch, and that will be having low latency. Yeah? So that is the stuff. You can like maintain inside data lake if you want, but latency will be very high. Latency will be very high. That is the thing that you need to keep in your mind now.
So what about the size? How much can we expect the size of Metastore can be at max?
Size. So metadata is not like having much size. That will be in MBs only. Yeah, the metadata will be in MBs only. Like if we are having terabytes of data, the size, it will be in KB or MB. It will be very less. It is not like say we will be having data in GBs and all. Until unless we are
Okay,
not
okay.
having until unless we are not having say billions of tables. If we are having billions of tables, then the size of the meta store may increase. But with respect
Okay.
to the tables, those are available inside the meta store, or the data with respect to the tables which is maintained inside the meta store, the metadata will be very less. Say if we are talking about this particular column, just have a look over here. Hmm. So if we are talking about this particular table, bucketing columns, so it is going to have the list. It is going to provide the outcome in this particular way. Say table ID, table ID, say tab ID, tab ID say one, column, bucketing bucket column uh, say sales. Okay, like the bucketization is done based upon the sales column, and another two or three things. This is say with respect to table one. With respect to say table two, we will be having another entry, say bucketing column, say category. Okay, so in this particular way, at this moment, like it might be possible the sales table what we are having, that is having billions of records, but its metadata, its bucketing column information is maintained with one line only, one row only. Okay. So do we really require a NoSQL database to maintain this much of data with respect to a Hive table? I think we can manage with RDBMS, right? Until unless we are not having huge amount of data, until and this is the structured data. This is the structured data, and no sparse records are there. So In that case as well, like if sparse records or blank records are not there, then what is the need of NoSQL database? So we can proceed with the SQL database only, RDBMS only, right?
Okay, sir. Okay, sir. So
So these
one more question was there regarding your surety. Like, what is the use of surety in Hive?
that is serialization and deserialization basically. Now, Sharday is nothing but serialization and deserialization. Now, okay. So once we are going to apply the optimization, these are nothing but with the help of this, like we can optimize our query, serialization and deserialization. Now, so from the optimization perspective, we can apply the serialization deserialization. We will see. So these are nothing but optimization related stuff,
Okay, sir.
right? Anybody having any doubt? Anything that you want to ask?
No, it's fine, Ashok.
Okay.
Ashok, this table is are kind of templates, predefined templates for data, or
Yes, yes, yes. Actually, from the developer's perspective, there is no need to worry about these particular tables. Once we are going to create tables inside the Hive, then
mm,
the data in these particular tables will be updated. This is meta store, right? It will be updated automatically. Once we are going to create a table inside Hive, then entry will be visible over here, inside the
okay,
TBLS. Table parameter and all, if we are having like certain skewed columns and all, so those particular parameters will be available over here, okay,
fine.
fine. So all out over here, like different stuff what we are able to see, say these shorting, that is nothing but an optimization. Serialization deserialization, that is nothing but optimization. Partitioning, that is nothing but optimization. Indexing, global views, functions, these are nothing but optimization related stuff, and like if we are going in detail with serialization deserialization, Swati, like once we need to serialization is nothing but changing data, okay, from say bytes to objects and objects to bytes, like once we are planning to transfer the data over the network, so then serialization and deserialization is being utilized, and if you are able to recall, like we are having uh, serialization in Spark as well, Java serialization or Cairo serialization,
Yes, sir.
so
The
Cairo
Cairo
serialization,
is there.
yes. So Cairo serialization, that is utilized in order to optimize your query. Okay. Minimize the latency. That is, you can say, an optimization technique that you can apply on top of the data. So same thing is available in Hive. And what I used to say, whatever we are going to discuss in Hive, those particular things will be replicated in Spark, like if you are having good focus on to Hive, then Spark will be very easy for you, okay. So bucketing we will be applying over here, and we will be applying in Spark as well. Partitioning, okay. Serialization deserialization we will see over there, partitioning and skewed, and all skewed columns we will discuss over there as well. Okay, most of the things like the optimization techniques perspective, whatever we are going to learn in Hive, those particular things will be replicated in Spark as well. Okay, we will see, friends. No need to worry. We are going to, once we are going to create tables. Okay, then we will be able to see the entries of those particular tables inside the meta store. I will walk you through with the content of the meta store once we are going to create the tables in Hive. There will not be any issue. Okay, moving further, what I have mentioned, like defaulted Derby for the Hadoop, but in our case, inside the Cloudera Quick Start VM, MySQL is the meta store for Hive. And how you will be able to change inside the conference configuration file hive site.xml. Okay, you can change the meta store if you want. So that is quite possible. It is not like you will not be able to change. That is completely feasible. You will be able to change. And why we are not storing our metadata inside the data lake? Because we need to change the metadata. And like if we are going to modify the metadata and we are accessing it from the data lake, then that will be very high latency job, and it is not preferred. That's why like metadata is stored inside the no, inside the rdbms, and the actual data is stored inside the HDFS. Perfectly fine so far. Okay, so let me try to take certain example. Uh, the difference between transactional system and analytical system. You need to tell me. So transaction system, over here we are going to analyze individual entry. And inside the analytical system, what we are going to analyze, large batch of data.
Historical
Fine.
data.
Yes, large batch of data or historical data. Perfectly fine. Okay, so over here we are working on to the recent data. Now your point. Over here we are working on to historical data. Fine. So latency, which one is having latency? Transaction system is having
Low latency.
low latency. Perfect. And analytical systems are having high
high
latency.
latency.
And inside the transaction system, if I'm talking about source, so this is single source, single data source. Over here we are having single data source, single data source. But once we are talking about the analytical system, we can do the analysis onto the multiple source, right? Multi source data. Okay, so these are like say certain differences with respect to the transactional system, although like we have gone through with these particular differences, but with the help of this particular uh, you can say table like mechanism, I just want to visualize you the differences between these two systems. Analysis onto the individual entry. Over here we are working on to the large batch of data. It is working on recent data. Then analytical systems are working onto the historical data. Latency is low, latency is high inside the analytical. It is working majorly onto the single source data, and analytical systems are working onto the multiple source of data. Then another difference, what I can say over here, update, update data is happening. Like say if you have done the transaction, then it will be updated everywhere. So updated is the key operation over here. Update data is key operation. But once we are talking about the analytical system, only read is the key operation. Key operation. So we just need to read the historical data and then proceed onto the analysis onto that particular data. So read is the key operation over here. Okay, so these are the differences between transactional system and analytical system. Now, uh, now, uh, now, if I want to use these transaction systems, so or if I'm having the transaction systems, then what are the examples of those particular transaction systems? So RDBMS is best suited for that. RDBMS and analytical system, data warehouse. What I can say, data warehouse. That is perfectly fine. Now, characteristics of data warehouse. Although, like we have seen, data warehouse. Warehouse. So what we are having over here, we will be having long running jobs. Long running jobs. Okay. So what I have mentioned, uh, like we are having huge amount of data, and that particular historical data or large batch of data, it might be possible that can take uh, very high time. It might be possible it will be processed in 1 minute, it can be processed in 1 hour, or it can be processed in 1 day. So what we will be having, long running jobs are available once we are talking about a data warehouse. Then data warehouse are optimized for read operations. Optimized for read operations. Like if you are planning, you think in this particular in that particular perspective. Say you are the data architect of your organization, then you need to choose from the database or data warehouse. And based upon the flavor of operation that you are going to perform, you need to choose a particular tool. So if you are dealing with say historical data, then definitely like you are going to select the warehouse, and you for that particular warehouse, data warehouse, where you want to perform the optimization. You want to perform the optimization based upon the read operations. So these particular data warehouses, what we are having, these particular warehouses are optimized for the read operations. It is not like say it is if you want to perform the update and all. So data warehouses are not meant to work onto the update related operations. So that is the characteristic of say data warehouse. Hold data from multiple sources, that is also characteristics. Whatever we have seen over here, like those particular things, uh, what I can say, the characteristics of data warehouse. Because like for the analytical system, we are going to leverage data warehouse, and based upon the interview question, just you need to mold your definition. Long running jobs are there, optimized for read operations, and uh, it is holding data from multiple sources. Multiple sources. And then what I can say, what can be the another characteristic of data warehouse? You just need to tell me what can be the characteristic for data warehouse. Long running job optimized for read operation, holding multiple data from multiple source. What can be another difference, or sorry, characteristic?
ETL.
Yes, bash suited for ETL operation. ETL operations, that is a characteristic of a data warehouse, perfectly fine. What else? Hold historical data. Hold historical data, that is also there. Then what I can say, data processing, may be hold or not real time. Okay, so data processing, these are the characteristics, and whatever we have seen over here, that is nothing but the characteristics. Now HQL, HQL, Hive query language. HQL, that is nothing but Hive query language. Hive query language. This is nothing but SQL like queries. SQL like queries. Uh, Queries we need to write. SQL like queries we need to write, and it converts in MR jobs. Those jobs will run on cluster, and finally we will be able to work on Hadoop cluster. Okay, what is the meaning of this? Like Hive query language. Hive query language is nothing but we are going to write down the SQL like queries, and these SQL like queries will converted into the MR jobs. Okay, so say we are going to write down, we have written a code or SQL query to join two tables. So that particular query, what we are going to fire, that will be converted into MR jobs. MR job is nothing but map reduce jobs, and these particular jobs will be fired onto the cluster, and finally, like what I can say, we will be able to utilize the Hadoop for the processing perspective. So what I can mention, say we are having Hadoop, Hadoop, and on top of this, like what can have, we are having Hive. Okay, and inside Hadoop, this is nothing but combination of HDFS plus MapReduce. Try to focus over here, friends. Okay, so what we are going to do with the help of HQL, so over here we are going to write down the code or queries in Hive or HQL, basically HQL, that is Hive query language. And what it will do, it will convert that particular code into Java. Okay, Java program that will be given to the MapReduce. Okay, that particular code will be given to the MapReduce, that is the processing framework, in order to do the analysis onto the data which is placed inside the HDFS. Okay, so what we are going to perform inside the Hive, we are going to write down the SQL like code in order to have the analysis onto top of data which is placed inside the HDFS, and we will be able to have a tabular view of that particular data, and then we will be able to do the analysis. Okay, so that is the motto of Hive query language. So with the help of this, we will be able to do the analysis on top of data which is placed inside the HDFS. Hive is utilized in order to do the analysis onto the data which is placed inside the HDFS. So let me repeat once again what we have covered in our today's session. So in today's session, what we have started Hive, and we have seen like what is Hive, and why we need to have Hive. So Hive is going to make the life of developers very easy, and with the help of this, we are just going to write down the code in SQL like language, and then it will be utilized in order to do the analysis of the data which is placed inside the HDFS by uh, by firing those particular queries onto the map reducer. Okay, and then we have gone through with two types of system: transaction systems and analytical system. These are the two types of systems in this particular world. And analytical systems where long running jobs are there, and Hive is a tool or a data warehouse which is used to solve the analytical problem. Then we have gone through with certain basics like database, data warehouse, and data lake. And database are having low latency, definitely, because these are working onto the monolithic systems, working onto the very less amount of data. Then we are having data warehouse, those are working onto the huge amount of data, and having the distributed processing framework. Okay, and these are best suitable for the ETL operations, are having more latency if we compare it with the database. Then we have gone through with the data lake, and data lakes are having high latency if we compare it with uh, database and data warehouse, and these are best suitable for ELT operations. And over here we will be having raw data. Okay, so data lake is nothing but object store. S3, that is from the Amazon side, simple storage solution, or SDFS, both of these are nothing but the data lake, where data is placed in the object format. Then we have seen like the Hive tables, like the intention why we need to have Hive. Intention for having Hive just for two reasons, like we just want to analyze the data by writing down the SQL queries, and we just want to visualize the data as well in terms of table. Analyze in terms by writing the SQL queries, and visualize in terms of tables. So Hive is saying just like use me, utilize me, and I will be able to solve both of the challenges that you are having, that you are facing, and I will solve your issues. And it is saying, say, I'm having two main parts, like the actual data that is residing inside the SDFS, and metadata that is residing in RDBMS. We can utilize any RDBMS over here in order to maintain the metadata. But I have mentioned, like, Derby is the default database or RDBMS inside the Hadoop, but Derby is having certain production issues, so MySQL is utilized as a RDBMS for maintaining the metadata. If we are opening, you can say MySQL, then we will be able to see, say, Metastore over there, and we are having uh, different tables over there which are utilized in order to capture the metadata of Hive tables. So metadata and actual data, these are the two components of Hive tables. Then we have gone through with certain differences, like the difference between transactional system and analytical system. And then we have gone through with the properties of data warehouse, and finally we have gone through with the HQL, that is nothing but Hive query language, and which is utilized in order to do the analysis of the data stored inside the HDFS on by writing the SQL queries, and those particular queries are processed by the MapReduce by converting that particular query into the Java code internally. That's it for this particular session, friend. Fine so far? Any confusion, anything that you want to ask? Let me stop recording.
What is agenda for next session?